Welcome to the introduction of Solidity. In this lecture, we're going to talk about contracts, constructors, and functions. Let's first see what the structure of a Solidity source file is. Here we can see a sample contract. On the top of every Solidity file there is a so-called version pragma, which tells us the lowest version of Solidity supported by the contract. After that, we have the contract and its name. Inside it we can put variables, mappings, constructors, functions, modifiers, etc. Now let's see a sample contract in more detail. Here we can have two contracts called ownedToken and tokenCreator. You can have multiple contracts declared in a Solidity file. As you can see, we can also call contracts from other contracts, as in this example. After this, we have the variable declarations owner and name, which are used to store the address of the owner of the contract and the name of the contract. Just below them, we have the constructor. Keep in mind that several versions before, a constructor was declared as a function with the same name like the contract. However, now we use the keyword constructor. So a constructor is a function that runs only once when the contract is deployed to a network. When we deploy this contract, we can send the variable name with it. This variable is saved in the state variable name, and our wallet address from which we deployed the contract with is saved in the state variable owner. Now we can use this reference to check and restrict functions to be used by someone else who's not the owner of the contract. Okay, now let's see what is the structure of a function. If you're familiar with JavaScript, functions look a lot like the ones there. However, we have some additional modifiers. After the function name, the variables that the function receives, we have visibility declarations, state mutability, and return types of the function. For visibility, we can have public, private, internal, and external. For the state mutability, we have pure, view, and payable. And in order to return some variables from a function, at the end we should add the keyword returns and in brackets the type of variables that we want to return. Here we can return more than one variable, so keep that in mind. Okay, let's look at the different types of visibility in more detail. As I said, we can have 4 different types of visibility: public, external, internal, and private. Those visibility declarations can be applied both to functions and variables, except for the keyword external, which is only for functions. When we declare a function, the default visibility of it is public. Basically, we can call this function internally and externally, and everyone has access to it. The external keyword works almost the same. However, when you try to call the functions internally, from within the contract or from another function in the contract, you will need to add this dot in front of the function name in order to access it. This might seem a little inconvenient, however, external functions can cause less gas sometimes, because sometimes they are more efficient when they receive large arrays of data. We can also have internal functions that can only be accessed internally from the current contract or from contracts deriving from it. And last but not least, we have private functions, which can only be accessed from the contract they are defined in. They are usable only internally in the same contract. Now let's see an example of external and public functions. Here we have a sample contract. At the first line, as you can see, I have declared a variable as external. If you try to do that, you will get an error and the contract will not compile. Remember, state variables do not have an external visibility. However, here I have created public and external functions. Both of them do the same operation, but the external function will cost less gas in the end. External functions are more efficient when they receive large arrays of data, so you can use them to make your contract more efficient. And at the end, I have declared a function in which I try to call the external function test2. However, I needed to specify it as this.test2 in order to access the external function internally. So remember, if you want to call external functions internally, you need to add the keyword this in front of the function. Now let's look at an example of internal and private functions. Here we have three contracts, C, D, and E. Contract C has one private function, two public functions, and internal function called compute. In contract D, if you try to call the function f of the contract C, we're going to get an error because the function is declared private and is visible only inside the contract that is defined in. Also, if you try to call the function compute from the contract D, we're also going to get an error because contract D is not derivative of contract C. However, contract E is derivative of C. If you can see, we have declared this with the keyword is. If you have any prior programming knowledge, this is called code inheritance. Because our contract is derivative of contract C, we can now call the compute function as this internal member of the contract C. Now let's talk about the state mutability of functions. We have three different modifiers for that. We have view, pure, and payable. If we declare a function to be a view function, we basically promise not to modify the state. Pure functions are derivatives of view functions. However, pure functions promise not only not to modify a state, but also not to read from state. In the next slides, we will see more specific restrictions to those functions. The last state mutability we can have is payable. Basically, the functions that are annotated with this modifier can receive ether and can make operations with those ethers. Now let's look at some examples. Here's an example of a view function you can create. This function takes two variables a and b and returns a times b plus 42 plus now. Now is a global variable that gives you the time now as a timestamp variable. When you have a view function, you cannot write to state variables, emit events, send ether, or call functions that are not pure or view functions. I have listed the things that you are not allowed in the view functions on the right side here. Now, pure functions have the same restrictions as view functions, as well as they cannot read from state variables. In this example, I have three pure functions. The first two functions take variables x and y and do some mathematical operations and return the result. The third one just returns a string of "you're awesome." Those are some perfect examples of pure functions that you can use. However, there are some additional restrictions that you should keep in mind, like you cannot access this.balance, address.balance, blocks, tx, msg variables, or call functions that are not marked as pure. Now let's see an example of payable function. In order to receive ether, you need to provide the payable keyword to a function. Otherwise, the function will reject all ether sent to it. In this example contract, we have a public declared variable with the amount of 0, and we have a payable function payMe. The variable message.value gives the amount of ether that we sent to the function and adds it to the variable amount. This is the basic of tokens creation on the Ethereum blockchain. In reality, it is a little bit more complicated, but the fundamentals are the same. So let's stop here and have some practice in our next lecture.